Good morning, everybody. Hope everyone out there can hear me okay. I'm Steph from Simply Rhino, and I'd like to welcome you all to the third and last webinar in this current series where we're focusing on product design with Rhino for Mac. Today's webinar will last approximately 30 minutes, and our presenter, as usual, is Phil Cook. Phil is an experienced product design professional and Simply Rhino's senior trainer. As we progress through today's webinar, please type any questions you have in and send them over to us. It's most likely that we'll answer these questions in our official Q&A session at the end of the presentation, but if we can answer them during the actual presentation, then we will. Please do note that the webinar is live and Rhino for Mac is in development, so if there are any software hitches as we progress through the presentation, then please bear with us. Today's webinar is being recorded, so you can watch it again, and it will be posted on our Rhino for Mac YouTube channel, and a link to that is available on the Rhino for Mac page on the Simply Rhino website. So now I'm going to hand over to Phil for the presentation. Over to you, please, Phil.
Morning, everybody. I'm Phil from Simply Rhino, and in this webinar today, we're going to follow on from the previous webinar a couple of weeks ago where we built our basic solid model. So today we're going to concentrate on adding a little detail into the model. So if you remember from the last webinar, we built our telephone handset, and looking at the underside of the handset here, I want to add some detail onto this face here. I want to add some buttons here, and I want to add a recessed earpiece detail here on this face. These faces themselves have curvature to them, so it's not immediately straightforward to add detail onto curved surfaces. So what we're going to do is to actually model the detail on a planar surface and then use a Rhino transformation command called flow along surface to orient the objects onto our curved surface. This is a particularly effective way of creating detail for concept designs. So if I just maximize this view here, let's take a look at this surface first of all. One of the things I need to establish is the width and length of this particular constituent surface in our poly surface here, and I can do this by going to the Analyze menu here and using the length query here, picking an edge and entering, and then the length is going to be reported back here. So you can see that's reporting back at 41.047 millimeters. Now to get the length of the center here, what I need to do is to extract a curve from this surface, because my edges, because they've got the fillets at the corner here, don't give me the full distance of the surface. So to take a curve from the surface here, I'm going to go to Curve from Objects and extract ISO curve, and this will take one of the parameter curves, either in the U as it's shown here or the V direction here. I can hit this toggle button here to change the direction. This will pull out one of the parameter curves from the surface. I can then use that curve and again use the length query here to find the length of that, so 74.297. Okay, so I'll just get rid of that curve now, so I don't need that. And in my bottom view now, what I can do is to create a rectangle that's essentially the same size as those measurements. I'll just round it up slightly, so 74.3 by 41, and this rectangle is going to be a reference for my geometry. So I'm going to move this now from the center line down to align with my x-axis here. So to do this, just start the move tool, hit the tab key, and then type in 0 to put this on a 0 along the y-axis here. So now I'm going to draw my buttons. So I'll just first of all take a line command here. I'm just going to mark out the center of this rectangle, and then take a circle here, and I'm going to draw my button. Let's say that I want this to have a radius of 4 millimeters. And as well as modeling the buttons here, I also want to create a recess that the buttons sit into. And I'm going to say that that recess is offset by 1/4 of a millimeter. So I'm going to pick the circle here, go to curve, offset, and offset curve, type in a distance here of 0.25, and pull the cursor outwards. So that represents my first button. Now going to create the remaining 11 buttons here. So pick these here, go to transform and copy, and I'm going to copy these by a distance of 11 millimeters here, and then I can mirror these two circles here about the x-axis to give me the result down here. So transform, mirror, and I can just use the x-axis object in the mirror tool here. Now I'm going to take some further copies at 11 millimeter distances along here. So transform, copy, and point to copy from. I'll pick a center here, and then I can establish a direction. Again, I can hit the tab key here to lock the direction should I wish, and I can type in 11 for the distance. Now, an interesting thing about the copy command here is that I can use these options: from last point, use last distance, use last direction, and I can essentially hold the key over here. Sorry, let's do this again. Seems I clicked a little too soon there. So transform, copy, distance is 11, and then got there in the end. Use these options here, and then hold the mouse over this way and just keep clicking, and I'll get copies spaced at 11 millimeters. Okay, so this represents the button spacing that I'd like to use at the moment. And I'm not going to worry too much about the position of these relative to this rectangle at the moment. So let me just use my layers a little bit more to give me some organization here in Rhino. So I'll pick this geometry and I'll move these onto a layer called 2D detail, and I'll make my layer called 3D detail active, and I'll create a little bit of geometry here. So I want to first of all create the geometry that's going to create the recess on the phone. So I'll create an extrusion from this curve here, and I'll extrude this by a distance of 0.5 millimeters each side. So to do this, I go to my solid menu and extrude planar curve and straight, check the both sides option, and type in the distance of 0.5. Okay, I'm going to give this object a color. So in the object properties here, the display color, rather than being by layer, I'm going to pick custom and then click on the little rectangle here and give this a custom color. This is just going to make it easier for me to actually pick the geometry later on. Then I'm going to pick the circle that's used for the button, and I'll extrude this with a solid both sides, and this time I'll use a height of 1 millimeter. And again, I'm going to add a custom color to this, again just to help my selections a little later on. And I'm also going to add a bit of a fillet to the top of the button here. So again, I'll use my solid fillet here, just as we did last week. solid fillet edge. Put a radius in of about 0.4 here on this top edge, and let that go. So now in my bottom view now I can pick my solids and copy these out, and again let's pick all these and copy them out. So use a distance of 11 again, and then use these options from last point, use last distance, last direction. Okay, and we've got our copies here. Now, it would help to group the buttons and the recesses together, and an easy way of selecting these is to go to my Edit menu and select objects by colour. Pick this object here, and then all the other objects of that colour will be selected. So I can then group them together, and now they'll all select as one go. Grouping doesn't change the geometry at all, doesn't actually join the geometry. It just means that the selection is easier. So again, I can select objects by colour, pick the extrusion here, and then group these together. So now let's take a look at how we can put these buttons onto this surface here. And this command is actually history enabled as well, which gives us some nice ability to adjust the output here, which is excellent for when we're designing a concept. So the command that I'm going to use here is called transform and orient to surface. Sorry, it's not. It's called transform flow along surface. So transform flow along surface from here. Before I run this, I'm going to turn on my history. Let's just clear that last command. So history, transform flow along surface, and pick the two groups that I want to flow, and enter to accept that. And then I'm going to use this option here, the plane option, and this describes the plane on which these objects sit, and that relates to this surface in terms of its length and its width when we do the orientation. Sorry, I clicked too soon there, so let's do this again. So it's history on, transform, flow along surface, pick the two sets of objects that we want to flow, use the plane object, describe the plane, and then click on the corresponding corner of the target surface, and you'll see the objects become oriented. So you'll see here that these objects now pick up the curvature of the curved surfaces that they're oriented onto. And if I used history to create this geometry, or sorry, if I used history to do the orient command, then, for example, if I want to move the position of these buttons onto this surface, I really only need to move the two-dimensional buttons here. Okay, and you'll see those update. And if I want to change the size of these buttons, for example, I could take the original buttons on the planar surface here and maybe make these slightly bigger. And you'll see in a moment that 3D geometry updates as well. Okay, so it's a very kind of cool way of being able to design an array of something in 2 dimensions and then update it automatically on the 3-dimensional object. Okay, I'm now going to take this geometry here, so all of this stuff here, and I'm going to copy it onto a new layer here called Boolean. And then I'm going to turn the other layers off just for the moment. And I'm going to just temporarily hide my buttons. So that's shortcut for that is on a Mac is Alt plus H. And now I'm going to do a Boolean difference between the solid body here and remove these buttons, the button recesses from the solid body. So to do this, I go to Solid and Difference, and essentially I pick the object that I want to keep and enter, and then make sure this Delete Input object is option is checked here, and then pick the objects that I want to remove, and then enter. And you'll see now that we've created our button recesses. I can now show in the buttons again, and now I can Boolean union these into the phone body. So again, it's a solid command, and it's a union that we're looking for this time. Pick the two pieces of geometry and enter. Okay, depending on which order you pick these will depend on the object color that you get in the end. So I'm just going to change this back to by layer here to restore my black default object color. Okay, so you can see now that we've got some reasonably good button detail here. Now obviously if we were making this for a molded model, then all of these components would be separate. But in this instance here, what we're looking at doing is creating a simple solid that we can create a rapid prototype from. So let's now take a look at how we can put in the recess for the earpiece. So just to save a little bit of time here, we're going to use a similar process to before. We're going to use a flow along surface process, and I've already measured this surface here, and it's 41 across here and 40 in this distance here. So I can turn on my 2D and 3D layer details here and create my rectangle here. Let's create it from a center here. Actually, let's not do that. Let's just create a rectangle here that's 40 by 41. Let's move this in this direction down to the axis. And I want really a circular recess, or a roughly circular recess here that's about 4 millimeters deep. So one of the ways that I can do this is to, first of all here, create a circle that's snapped to the center of this rectangle, and let's say I'll give this a radius of 15 millimeters. I'm then going to mark some points here at a midpoint and an end point here. These would also be quad points on the circle, and a center point. So I've got 3 points here. And then in this view here, I'm going to make sure my project's turned on here, and in my front view, I'm going to push this point upwards by 4 millimeters. And so the recess that I want to create is part of a sphere. So an easy way of creating that recess then is to create a sphere and use the sphere by 3 points option here. And I can then create my sphere through these 3 points. Just make sure I snap to the right. There he is here. Turn off this center snap. So point and point. Okay, and that creates my sphere. Now you'll see that the sphere, of course, is a single surface in Rhino, and it has a seam on it. And that seam is going to be running right through the area where that I'm going to use for my recess. And it would be a little better if that wasn't happening. So I'm just simply going to take the sphere now and then rotate it through 90 degrees just to move the seam out of the way. Then in my front view, I can create a line and just trim away most of the excess sphere that I don't use. I'm going to just leave a little bit sticking above my line here. Okay, so this is the recessed feature that I'm going to add onto here. And before I do this, I want to add just some little holes in here for the speaker. So I'll switch to wireframe mode here, just turn project off now, and I'll create a circle here with a radius of, let's say, 1 millimeter. And then I'll move that circle by 4 millimeters here, and then I'll create a radial or circular array here of these. So I'll do this with transform and array polar. Pick the center of the polar array, which is going to be the center of the circle. And number of items, I'll say I want 7 of these, and I want them arrayed through 360 degrees. This command gives you a preview, and I can change the fill angle and the number of items while I'm in the preview mode, and then I can enter to accept the result. I'm just going to pick these objects here and just move them down just slightly by eye here, and then I've got to pick the 7 curves, and I'm going to extrude these with a solid. I don't need the both sides option this time. And just make sure these pass through the cylinder, pass through the portion of the sphere. Okay, so now we've got the cylinders passing through here. And next up, I'm going to actually remove the cylinders from this surface. Now, I'm going to use a Boolean tool to do this. The Boolean tools are essentially designed to work on solid objects, and in Rhino the solid objects always have a normal direction that points outwards, and with a surface the normal direction can point either inwards or outwards. I can check the normal direction here, and you'll see that the normal direction is effectively pointing inwards from what I would consider to be the top of my surface. So I can flip this and then enter to accept that. And now I can use something like a Boolean difference command and get a result which is predictable. So I can run a difference now, and hopefully the result that I'll get will be to remove the cylinders from the trimmed sphere. There is also a Boolean toObjects command that gives you all the Boolean options, but you can only pick 2 objects at once. So here, obviously, I've got a number of objects that I'm using. Just add a small fillet here onto these edges. Let's say 0.2 millimeters around these edges here. And then I can use a flow along surface to orient this to this curved surface. So it's a transform command, a flow along surface, pick the objects that I want to flow, enter, use the plane command, and then click on the corresponding corner. Okay, so in this instance here, where you see this thing happening, where this is working in reverse, then you can try either clicking on a different corner, which will give us the correct result, or we can change normal directions of that object as well. So sometimes there is you need to try a couple of times with flow along surface to get the right result, because it relies on UV direction of the surfaces and normal direction as well. Okay, I'm going to move that poly surface over to my Boolean layer. And now let's have a look at a command called Boolean to objects. This is the command that gives me all the possible iterations here, and I get a nice preview of this. I just need to left click, and as I left click here, I'll see all the possible Booleans I can get here. When I get the result that I expect, I can enter to give me the desired result. Okay, so time's running on a bit now, so very quickly now I'm just going to go through the steps that we would use now to create an STL file from this geometry. First step is that we want to make sure that our geometry here in Rhino is solid. This is very important, and I don't by solid I mean that it's a watertight solid with no naked edges. To do this, I can pick the geometry here, go to my Analyze menu, go to Edge Tools and Show Edges. If I pick a nice bright color here for the edges, I'll see any naked edges if I have naked edges selected here, and at the bottom of the Rhino window here, it will tell me there's no naked edges, no non-manifold edges. This is good news, it means we've got a manifold solid, and this is the first step of a successful STL. So step 2 is to take this geometry and use this command here, which is mesh from surface or polysurface. And you will see either some simple options here or some detailed options. My suggestion here is that we use the detailed options. There's lots of different ways of configuring these meshes by density, maximum angle, etc. And if you set a value to 0, that value is value is effectively overridden. So here we're only using the one control here, which is maximum distance edge to surface, and I'm setting this to 0.01 of a millimeters, which is kind of roughly the tolerance that a 3D printer would work to. We don't need a finer mesh than that because it'll be wasted on a 3D print. This means that the surfaces will pull up to 0.01 or rather the meshes will pull up to 0.01 of a millimeters to our NURBS object. I'm going to check simple planes here and refine mesh, and then accept the result here. The mesh now, I'll just move onto my mesh layer. Turn that on, turn the other layers off. We now have a mesh object here, and you'll notice that Rhino produces predominantly quad meshes here. Now, STL files are tri-meshes, so one of the things I can do now is to pick the object here, pick the mesh, and I'm just going to type this command in. There's a command in Rhino called triangulate mesh, and this will basically generate a triangular meshes from all my quad meshes. So this is almost ready to run out as an STL now. I just want to check again that I don't have any naked edges or non-manifold edges here. So pick the mesh, use exactly the same tool that we've used before, Edge Tools, Show Edges, and Rhino will report here that there's no naked edges, no non-manifold edges. So this is now a valid watertight mesh that's composed of tri-meshes. So this will be fine for an STL export. So pick the object, File, Export selected, and then I can write this out as an STL file. And the options that I want to choose here is the binary option, and I want to make sure that I uncheck Export Open Objects. Most 3D printers and rapid prototyping machines won't accept open STL objects. They need a closed volume. So this is the sure way of making sure that your geometry is good for STL. Okay, so that's probably what I wanted to go through to today. So I'll hand you back to Steph and Paul.
Thank you. Thanks, Phil. That was great. Okay, so I'm going to hand over to Paul now because I think he's got a couple of questions. So, Paul, would you like to carry on with those, please?
Yes, thanks, Steph. Hi, Phil. Okay, well, there is only the one question that I can see, and it's a question about, oh no, there may be another one, but okay, well, first question, how robust is history, and what sort of operations will break history?
Okay, so history is essentially an association between objects, and history is pretty robust. It's saved with a file, but you need to think of history as being like a dependency between, let's say, a parent object, a child object, and let's say a grandchild. And if using that analogy, the parent was controlling the history, if I modified the child object without modifying the parent, then I'd break the history between the parent and the child. So it's a case really as that you're having this kind of linear relationship between the objects, and if you disrupt that relationship, then you'll break the chain of history.
Okay, thanks. One other thing, just regarding normals. I think as part of your process this morning, you were changing the direction of normals.
Yes.
There's just a sort of a question around that regarding, is that something that you have to be aware of often and look at as part of a modeling process, from minute to minute, or how important is that aspect of
essentially
control?
No. If you have, for example, in normal modeling, if you have a couple of surfaces with different normal directions and you join them together, Rhino just takes care of the normal direction and unifies that. There is only the one, or there are only a few times where this becomes important, and one of the times is using Boolean operations on surfaces. So Boolean operations are really designed to work on solids. a solid in Rhino always has the normal direction pointing outwards, where of course a surface like the part of the sphere that we use, the trimmed part of the sphere, could have the normal direction pointing either inwards or outwards. And the normal directions basically govern, in the case of a Boolean, in simple terms, whether it's going to give a union or a subtraction. So to make sure that we don't get a surprising result, we can check the normal direction before we run the Boolean command. If you only have a couple of objects, then again you don't need to worry about the Boolean picking up on the direction, because you can use the Boolean to objects command that we used a little later on in the exercise, and that will give you all the possible Boolean results. So in short, it's not something that you need to overly be concerned about. There are just a couple of specific occasions where normals become more important.
Great. Okay, that's the end of the questions. So I'd just like to thank Phil and Steph and everybody for attending. Any questions, any further questions, of course, please feel free to email those to us. You can contact us via the website simplyrhino.co.uk. There is also an important sort of registration page that's available via the home page, which we're going to have some very interesting news to be able to tell you very shortly regarding the launch of Rhino for Mac. So if you want to know more about that, either call us or register your details via the link on our homepage. Other than that, I think it's keep an eye on our website for the further Rhino for Mac tutorials, and we will be announcing future webinars on an ongoing basis. Other than that, thank you everybody, and goodbye.